Right, the section says to evaluate the integrals using the method of partial fractions. So I do know that I'm going to be doing some factoring and separating. The one thing that I do want to check for in these problems is to make sure I don't have to do long division before I actually start the problem. I'm set on this one because the degree of the numerator is not greater than or equal to the degree of the denominator. So I'm actually ready to start factoring this. This is going to be equivalent to 11x minus 15 over, I could factor out an x, so I'll have 4x minus 3. And then from here we will turn it into, actually, nope, we're going to separate it on this one. I'm going to have a over x plus b over 4x minus 3. And then I will have 11x minus 15 over x times 4x minus 3 will equal, getting a common denominator, I'll have a over a times 4x minus 3 plus bx all over x times 4x minus 3. Remember, we'll set the numerators equal to each other, so I'll have 11x minus 15 is equal to a times 4x minus 3 plus bx. And then from here, we're going to pick some choices for x. I'll choose the easiest one first. Let's let x equal 0. So if I plug 0 in everywhere I see an x in the problem, I'll get negative 15 is equal to negative 3a, which means a will equal 5. And then from here, let's let x equal, we would have to let it equal 3/4. So if x is equal to 3/4, the a will drop out. Whoops, let's do it here. This will, I think, end up being 33. Let's see if we'll have 33/4 minus 15. And then that will equal, that will drop out, and then I'll get 3/4 b. All right, oh, this is a fun problem, isn't it? Okay, so then I'll have 33/4 minus 60/4 will equal 3/4 b. 33/4 minus 60/4 is negative 27/4 will equal 3/4 b, and then we'll multiply by the reciprocal. So we will multiply by 4/3, and when we do that, oh, b turns out to be nice. Good. Right, so we get b is equal to negative 9. So we have just turned this problem into the integral of 5 over x plus the integral of negative 9 over 4x minus 3. So this first one, the integral of that will just be 5 natural log of x. This one we're going to have to do a little bit more work for. We will actually have to do our u substitution on this problem, sorry. We'll let u equal 4x minus 3, which means du will be 4. I want a 4 here, so I'm going to multiply by negative 4/9, which means on the outside I'm going to multiply by negative 9/4. So now this will now turn into negative 9/4 integral of du over u. So now I will have 5 natural log of x minus 9/4 natural log of u, which will be 4x minus 3. And then I will go ahead on this one. If we moved our powers, we'll have the ln of x to the 5th minus the natural log of 4x minus 3 to the 9/4. And then I can combine them, so I'll have the natural log of x to the 5th over, oops, I got my x there, 4x minus 3 raised to the 9/4, and then plus c. Okay, next one we have the integral of x over x squared plus 7x minus 18. It did say to use partial fractions. I do notice that I don't have to do long division because the degree of the numerator is not greater than or equal to the degree of the denominator. So I am ready to go ahead and factor. That will factor as x plus 9 times x minus 2. And then I get to separate it into a over x plus 9 plus b over x minus 2. And then when I rewrite the denominators, I'll get x equals a times x minus 2 plus b times the quantity x plus 9. I'm ready to solve for a and b. First of all, I'm going to let x equal 2. And if I do that, I'm going to get 2 equals 11b, which means b is equal to 2/11. And then when we let x equal negative 9, we've got negative 9 equals negative 11a. So a will equal a positive 9/11ths. So when I write my integrals, I'll have negative, nope, that's just positive. It'll just be 9/11ths over x plus 9 plus the integral of 2/11ths over x minus 2. And then I'm ready to go ahead and take the integral. I'll get 9/11ths natural log 11. Natural log x plus 9 plus 2/11ths natural log x minus 2. And then since they're, whoops, we can't put them together yet. I think in my answer I just left it like that. We could leave it like that, but if we would like to work it farther, what I would do is we've got the natural log of x plus 9 to the 9/11ths plus the natural log of x minus 2 to 2/11ths. And then we could combine those, so I'm going to have the natural log of x plus 9 to the 9/11ths times x minus 2 to the 2/11ths plus c. And as long as we're not doing a limit for these problems, that would be okay to leave it like this.